Hello, welcome back to Algebra 1 with Miss Betsy. We are finally at the last section of Chapter 6. We are in Section 6.10 and we are going to be graphing linear inequalities today. And I could almost get excited about it because here's my teacher's edition and look at this. I'm at the very end of the book. However, I have a second volume to my teacher's edition, but that tells you we're halfway through our text, which is really good. We're doing just fine. And I think you're going to enjoy today's lecture. Before we begin, as I promised you, I said no more piggy riddles. Back to our lame dinosaur jokes. What do you call a dinosaur with a headache? You call him, my head is very saurus. So yes, I really honestly did go and buy a lame coloring book. This is, remember, I think I've shown you, what do you call a scared dinosaur? He's a nervous Rex. Anyway, I'm going to find some new material for some jokes and see just how lame I can get. But what we're going to do today is we are going to graph linear inequalities. And linear inequalities are similar to equations. Like a linear equation you've learned is the graph of a straight line. Well, a linear equality, you're going to deal with it in much the same way as you would deal with the graph of a straight line, but it's going to can include more values than just what you would have just a straight line. For example, let's say that you had, back to when we were graphing numbers on a straight line, and you had this thing, and they asked you to graph on a number line where x is equal to 3. You would have 0, and you would 3, and the dot would indicate the point on the number line that would be the graph of the value x is equal to 3. And as we moved on now to graphing equations, you've learned that actually, if you have the equation of a line where x is equal to 3, that's a vertical line that goes through the point where x is equal to 3. Let me pause just a minute and turn this phone off because it's running out of power and it's going to be beeping. Now, this was how you graphed a point on the line. However, if we change that from an equality to an inequality and said x was greater than 3, what that meant was that any point to the right of 3 on the number line is a part of the solution. Because x is greater than 3, the number itself is not a part of the solution, but any number, 7, 85, 2,973,000.72, all of those are solutions to this inequality. And it's going to be similar to that when we're graphing linear inequalities on a number line. So, without further ado, let's just go ahead and see what we can come up with. What happens is, just like, let me back up just a minute, just like when we have this when we have this inequality here, x is greater than 6, what this actually, greater than or equal to 6, what this actually did was it divided our number line up into two parts, didn't it? One part of the number line was included in the solution. The other part of the number line is not included in the solution. And that's exactly what's going to happen when we graph a linear equation. That is, instead of being an equation, a linear equality, it's a linear inequality. And it's going to divide your plane up into two parts, where half of it's a part of the solution, and the other half of it is not a part of the solution. Let's go ahead now and use these grids that I already have up on the board and see what we end up with. Example number 1. Okay, for those of you who are tracking with me, I'm in Bob Jones University Press, Algebra 1 for Christian Schools, 2nd edition. I'm in section 6.10, which is graphing linear inequalities. I'm on page beginning 262. I'm on page 263 now. You can use any Algebra 1 book. Some of this stuff is even in some of your elementary college algebra books. You can still gain information as to how to graph linear inequalities. Example number 1 says, graph 2x plus y is greater than 3. 2x plus y, is greater than 3. Now, what did you have to do when you were going to just graph a straight line? If this had been 2x plus y is equal to 3, what did you do first? That's right, you solve for y. So this is what we're going to do now. We're going to solve this inequality for y by subtracting a 2x from both sides of the equation. You know how to do this. We have now solved our inequality for y, and we have y is greater than negative 2x plus 3. But we're going to think of this as being an equation, and if we, an equal sign rather. And if we had y is equal to negative 2x plus 3, what would be the y-intercept and the slope of, they're calling it the corresponding equality. The slope would be a negative 2, and the y-intercept, or b, would be 3. What we've done is we've solved this inequality for y. It's an inequality because it's greater than, it's not equal to. And they ask you to say, what would be the slope and the y-intercept of the corresponding equality? This right here, y is equal to negative 2x plus 3. This is what they're referring to as the corresponding equality. Think of what this would look like if you had an equal sign. If you had an equal sign here, you would recognize that the slope was a negative 2, and the y-intercept is a 3, which means that the graph of this equation here crosses the y-axis at the point 0, 3 on the number line. So now we have the slope is negative 2, and we have b is a positive 3. Now, let's go back to what I was showing you briefly at the beginning. We're going to say x is equal to 0. I'm sorry, x is greater than 0. And we're going to say x is greater than or equal to 0. How do we graph this? If the value itself is not included, remember we had an open circle and shaded in everything to the right. If the number itself was included in the solution, if x could be equal to 0 or greater than, that was a solid circle, and we also included everything to the right. We have the same thing going on when we are graphing inequalities. Now, are we using circles anywhere to indicate the graph of this an equation? No. We're representing a straight line. Well, the straight line is going to be like our solid circle, and a dotted line is going to be like our open circle. So what we're going to do, we've been given the slope of the line, and we've been given the y-intercept. Our y-intercept here is 3. And our slope is a negative 2. What does that mean? That means we're going to move 2 units down and 1 unit to the right. Now, if we were going to graph this corresponding equality, we just connect the lines. But it's an inequality. And because it doesn't have that equal sign there, what that means is this straight line, this line here, the actual line itself, is not a part of the solution. So what we're going to do is use our version of an open circle. And I forgot to bring my straight edge with me. So I'm going to use my book, and I'm going to make a dotted line here instead of a solid line because the line itself is not a part of the solution because there's no equal sign. It just says y has to be greater than negative 2x plus 3. So I've graphed this line, labeled the points, x is 0, y is 3. X is 1, y is 1. Instead of I did not use a straight line because I don't have an equal sign over here in my inequality. Now if this had been greater than or equal to, I would have made a solid line. Now what's happened? We have this line here has divided our plane into two sections, just like the point on the number line divides our number line into two sections. So what that means is one whole part of the plane is a part of the solution. One whole part of the plane is not a part of the solution. And how do you know which is which? Well, what you're going to do is pick a test point. Now remember what I've said about how you always want to look for some really easy numbers. Who's interested in doing any more complicated calculation than necessary? You want to make this simple for yourself. So what you're going to do is you're going to look for one point that's not on the line that would be a good, easy thing to substitute. And this is what you're going to use. Use the origin. What's the origin? The origin is the point 0, 0. As your test point, if possible. How do you know if it can be possible or not? As long as the line the graph of the inequality doesn't pass through the origin, you can use it. Is it going through the origin now? No. So this is going to be my test point. And I take that test point there, and I substitute this into the original inequality. And I'm looking for my cover here. And I say 2x plus y greater than 3. 2x plus y is greater than, not 0. 2x plus y greater than 3. Going to use 0, 0 as my test point. 2 times 0 plus 0. Is that greater than 3? Is 0 greater than 3? No. 0 is not greater than 3. Is this a true solution? Does this work? No. If the test point is not as part of the solution, then nothing over here is a part of the solution, which means that everything on the other side is a part of your solution. And this is how you finish your graph. You shade the part of your graph that is the solution. How do you know what side you shade? You pick a test point. When you put that test point in, if you come up with a true statement, if the test point makes a true statement, then that whole side is a part of the solution. If the test point does not make your inequality true, then nothing over here is true, and the opposite part of the graph is shaded. Okay? Let's go ahead and do another example. Oh, and of course, don't forget to label this. This was the line. Y is greater than, that's a -2 slope, -2x plus 3. always need to make sure that you label your line, the graph of your line. Let me reiterate how you tell which side you're going to graph. Very top of page 264. If the point you choose as your test point, 0, 0, makes the inequality true, all the points on that side make it true. And you're going to shade that same side. However, if that's false, none of those are going to work. None of those are going to be a part of your solution, so you shade the opposite side. Goes back to when you were beginning how to learn what side of a grid to shade. You have x greater than 5. Pick a point over here. Is 0 greater than 5? Well, no. Nothing over here is a part of it. So x greater than 5 meant everything to the right of the number line. Now let's go ahead and do another graph. See what we have here. Graph 6x minus 2y is greater than or equal to 10. Now there's a lot of review going on here. 6x minus 2y is greater than or equal to 10. What do you have to do to graph a straight line? You put this into y-intercept form, right? We're going to do this by subtracting a 6x from both sides of the equation. 6x minus 2y greater than or equal to negative 6x plus 10. Subtracted a 6x from both sides of that inequality. Now we have negative 2y is greater than or equal to negative 6x plus 10. You should all have no problem tracking with me on that one. Now what do I have to do? I have to divide both sides of the equation by negative 2, don't I? What happens with inequalities when you divide by a negative? This is what your little kicker is here. Divide or multiply an inequality by a negative number. What happens? What happens if you divide or multiply an inequality by a negative number? Reverse the inequality. Remember this? Reverse the inequality. Has nothing to do with adding or subtracting. Has nothing to do with adding or subtracting negative numbers. It's when you multiply or divide an inequality by a negative number, the direction of that inequality has to reverse. And of course here we're going to have to divide by negative 2, don't we? So we have y is greater than or equal negative 6x divided by negative 2 plus 10 divided by negative 2. And I split it up like this, remember, because we want to be able to have our slope and our y-intercept. So what do we have now? Y is greater than or equal to 3x minus 5. Everybody take a second or 2 or 10, pause the tape if you need to, and make absolutely certain that you understand how I came up with y is greater than or equal to 3x minus 5, because that's absolutely essential that you understand that. Now, isn't this very interesting? I spoke and I said reverse the direction of the inequality. Did I do it? No. It's possible to even sit here and teach it and make a big point out of it. Now, what should that be telling you? It should be telling you that it's really, really, really easy to get going. And to forget to reverse the direction of your inequality. If I were studying, I would be making a really, 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 really big deal in my notes, because I'd be sitting here laughing, saying, goodness, Miss Betsy's teaching this. She's making a really big deal about when you multiply or divide by a negative number, you reverse the direction of the inequality, and then she didn't even do it. It's a big deal. It'll trip you up, okay? Now what do? You go ahead and graph this as if it were a straight line. Where's my y-intercept? It's at -5. And what is my slope going to be equal to? The slope is a +3. 3/1, the rise over run. For every 3 units that you go up 1, you go to the right 1. Now we have plotted 2 points, and we can go ahead and connect those. It's an inequality. Am I going to use a dotted line or a dashed line? Or am I going to use a solid line to graph this? Well, I'm going to use a solid line because I have y is less than or equal to. Because it says equal to, it's going to be a solid line. One, two, three, one, three, one. Well, still didn't quite get those dots connected. So we'll just do that for the camera and say that those dots are on the same line. We have a solid line because its y is less than or equal to. Now what do? How do we know which side of this graph we're going to shade? You pick a test point, plug that test point into the original equation, and see what happens. What's my original equation? 6x minus 2y is greater than or equal to, is that greater than or equal to 10? What's going to happen when I plug zeros in? I'm going to end up with 0. Is 0 greater than or equal to 10? No way. 0 is less than 10, so nothing on that side fulfills the solution. That means all the rest of the plane on the other side, that right there, is a part of the solution. Shall I go ahead and do one more? Let me go ahead and do one more from your homework. Let me go ahead and graph number, I don't know. Let's just do 3x plus y greater than 12. I don't even remember what number that is. 3x plus y greater than 12. This is number 4. 3x plus y greater than 12. It's an inequality. Doesn't have an equal sign, so you know the graph of the line is going to be a dashed or a broken line. We solve this for y. We have y is greater than a minus 3x plus 12. What would I do? This is an inconvenient one to graph. So what I might do here is, on my next graph, I might do 2, 4, 6, 8, 10, 12. So I'm not going to graph this. I'll sketch it for you. Right here is 12, 2, 3, 6, 9, 12, 3, 6, 9. The y-intercept is 12. I go down 3 and over 1. So it's going to look roughly like that. Is 0 greater than 12? No. So this side of the inequality is going to be shaded. And you saw how quickly I sketched that? Wasn't neat? That was a perfect example of me not just not picking a really good problem to do for you. So let's pick this one. How about if we said 2x plus y is equal to, is greater than or equal to 2. What do? We solve for y. Y is greater than or equal to a negative 2x plus 2. Now this is one that we can graph very easily, isn't it? Has a slope of a negative 2, so it's going downhill. It crosses the y-axis at the point 0, 2. Because we have y is greater than or equal to this, the graph of my line itself is going to be a solid line because it's part of a solution. So let's go ahead and graph this. The y-intercept is 2, x is 0, and y is 2. It has a slope of a negative 2, so we go down 2 and over 1. X is 1, y is 0. We're going to connect the line with a solid line. And I'm going to work really, really hard to connect those properly. There's the graph of the line itself. I'm going to label this 2x plus y is greater than or equal to 2. Now I'm going to try my test point, which is 0, 0. I'm going to say 0 plus 0, is that greater than or equal to 2? No, it's not. So that means the solution is everything on the other side of the line, as well as every part of the line itself, because we have that equal sign here. Now let me do one final example for you. And give you one where we can't use 0, 0 as the test point. How about y is greater than x? What's our slope here? The slope is 1. What's our y-intercept? It's 0. This is actually direct variation right here. But right here we have y is greater than x. Let's go ahead and plot this. It's going to be a broken line, isn't it? Because it does not include that equal sign. It intersects at the origin. The slope is a positive 1. So I'm going to have the origin, which is 0, 0. And I'm going to use just 2, 2 as another point because I went up 1 over 1, up 1 over 1. So they would be spread out a little bit. Let me connect the dots with a broken line because there's no equal sign. So those lines, those ordered pairs that actually lie on the line are not a part of the solution. Oh, phooey. Let me see what I can do to make this better. The problem with using whiteboard on a paper is that I get accustomed to doing things one way, and I can't continue it. This is a broken line. It's not a solid line. It's really easy when you use a whiteboard. If you want to do a broken line, we're graphing this through the origin, and then you just go through and erase it, and all of a sudden it's a broken line. But you can't do it, so I've remarked this. So we have a broken line for our graph because the line itself is not a part of the solution. Now, we want to use, what are we going to use as a test point? Well, we can't use the origin because the line goes right through that. So just pick another line, pick another number. That's easy. How about this point right here, the point 2, 0. I'm sorry, the point 0, 2. X is 0 and Y is 2. This is going to be my test point. Test point. And no, it's not toilet paper. It just happens to be the test point. If X is 2 and Y is 0, is 0 greater than 2? No, 0 isn't greater than 2. So the solution is every ordered pair on the opposite side of the graph. So it's no big deal. If you can't use the point 0, 0 as a test point, just pick something convenient. Otherwise, the majority of the time, you're going to be able to use 0, 0 as your test point. It makes your arithmetic a little bit easier, and these are the graphs that you come up with. So that is the end of Chapter 6. We're now halfway through the book, and I'm so very proud of you. I'll see you next time.